Okay, we need to look at one more thing today with these tangents. Now, we looked in the last section at the fact that when we have a tangent, it's always going to make a right angle. And we're going to kind of build off of that. So the next thing we need to take a look at is the fact that if we have two right angles, these segments that are going up to a point where they're meeting are always going to be the same. They're always going to be the same length. Okay, so for example, we can use this idea to help us find some missing lengths and to find some missing angles. Notice that we know that both of these angles must be right angles, right? We're told that they are tangents, so we can know that these are right angles. Because these are both the radius, we know that both of those lengths from the center to the outside of the circle have to be equal. And now our new property says that these lengths going from our point of tangency out to that common point also have to be equal. Okay, so we're going to use this to find angles and lengths. This first problem here is taking a look at if we know that these lines are tangent, can we find the measure of this angle? Now I want you to notice that we have 4 angles here. We looked at this earlier that with polygons, any shape that has 4 sides is always going to add up to 360. And so kind of connecting back to that idea with polygons, if I add up my angles that I know right now, I have a 35. I also have these two 90s. And if I go ahead and add up my 3 angles that I know, I'm going to get 200. That's not right. It's not 215, it's 315. Let's try that again. If I add these up, I know that I'm going to get 315, which means if I know they have to add up to 360, then this angle right here has to be 45 degrees. Okay, let's take a look at another one. Now here we know, again, that there's 2 points, 2 tangent lines, right here, which means we know that we have right angles. We know that these radius are always going to be the same length. We also know that these lengths are going to be the same. And so this problem is telling us that if Tx is 12 and Tz, this length here, is 20, what are, let's see, we're looking for xz, which is this line here, and we're looking for yz, which is this length over here. Okay, so let's think about this. We know that that line on the inside is 20. We actually know that both of these are 12, right? And notice again, we end up with that triangle that we can solve. So we know this is 12. We see that our hypotenuse is 20. We're missing this side, and so I'm going to go ahead and plug that into my Pythagorean theorem. I know it's a triangle, so I know I can find that other side. Okay, so as I go through my Pythagorean, I want to find out what my x is. So I get 144 plus x squared is equal to 400, right? Which means x squared is equal to 256. Make sure you're taking that square root. So if we want the square root of 256, it means x is equal to 16. So again, we're using these properties of tangents, but we're also going back and looking at, it's really a triangle with tangents that we're dealing with, right? Both of these lengths are 16 long.